Здравствуйте. The title of my project is Bagging of Convolutional Neural Network for Diagnostic of Eye Disease, presented by Mahmoud Smaida, supervised Dr. Yaroshchak from National University of Water and Environment Engineering in Revine. Presentation layout, introduction, proposed system, methodology, seen in architecture, dataset, inception, learning, and bagging. ICs have a large variety of forms that texture are sometimes hard to be identified and recognized by optometrists. Therefore, using information technology to improve a current system must be made to provide maximum comfortable to the patient and optometrist and improve the healthcare. In this paper, we will use bagging method for diagnostics of eye diseases using three different scenes in architecture. The main subject of the main name of my project is development of a neural network algorithm for automation of early diagnosis of eye disease. We have three types of eye disease and normal eyes. We want to classify four classes, and we want the neural network to predict to predict and classify the eye's disease. The methodology we use three methods are studied in this paper in order to evaluate our classifier using bagging method. The scene in consists the first architecture is seen in consists three hidden layer and pooling layer. The second architecture is a pre-training scene based on Vgg16, and the third one is a pre-training scene based on EnceptionV3. And these are the figure of the three scene architecture. Database. Our database is collected from Kaggle, from computation in Kaggle, diabetic retinopathy detection, and glaucoma detection. We collected a number of, we collecting 975 from diabetic retinopathy and 721 glaucoma, myopia 486, and normal eyes 599. And we met some optometrists in some clinics in Kiev, and we discuss about the eyes disease and classify all the database. Ensemble learning, the main case of error in learning model are due to noisy, bias, and variance. Ensemble method helps to minimize these vectors. That's why we are using bagging or ensemble learning to minimize the variance to avoid the overfit. Ensemble learning method are a technique that combine a several-based method to creating a perfect predictive model. And it's divided into three techniques: bagging, posting, and stacking. And we will focus on just bagging. bagging technique. In this paper, we will focus on bagging ensemble, which is types of ensemble learning that really on creating number of sub data set called bagging. Each bag is a subset of the original dataset. Usually we do 60% from our data each bag with replacement. We use each of these collection of data to train the different model. Finally, collect all the output and collect or calculate the average or voting value. Our result is we obtain the result, we apply it, we implement the three models of multi-classification, three models of bullshit. Three models of multi-classification seen in Vgg and EnceptionV3 have been compared in order to measure the model accuracy and to know the effect of model sampling compared with learning algorithm alone. Using Python model mentioned above are deployed using Python for multi-class image classification in Google Colab, and so as shown in the table, we obtained a result for each combination and observed that bagging based on EnceptionV3 and combine all the model, the CNN model it gives better classification accuracy, 87 and 86% than any other models. Three models of multi-classification seen in Vgg and EnceptionV3 have been compared in order to measure the model accuracy and to know the effect of models assembling compared with learning algorithm alone. All the models mentioned above are deployed using Python for multi-class image classification in Google Colab, as it's shown in the table. We obtained result for each combination and observed that bagging based on EnceptionV3 and combining all the CNN architecture gives better classification accuracy than any other models. We got 70, 87 and 86.5% and it's not excellent score, but it's a good score. It's better than we use algorithm alone. In our paper, we in our system we use it a confusion matrix, and we know where our classify is confused. Our classifier is confused in glaucoma and normal. He cannot he cannot distinct it. He cannot finally, thank you for listening, and thank you for finally, thank you for listening, and bye bye.